Hey guys, I'm going to teach you how to graph linear inequalities. By the end of this lesson, you'll be able to identify the solution set of a linear inequality on a graph. So go ahead and get your binder, turn to the math section, and let's go ahead and take some notes. Start out with Jake and TJ. They're solving these two problems below. I want you to solve each one of these problems, and then let's start by listing similarities and differences between those problems. What you should have noticed is that whether this was an equation or an inequality, we solve each problem with the same steps. So it looks like we get the same answer, -2, -2. However, the key difference between these two problems is that in Jake's equation, there's only one solution. X is -2. While in TJ's problem, he has an inequality. His answer is all numbers that are greater than -2. Also, don't forget that in TJ's problem with an inequality, since he divided by -6, he has to remember to flip the sign. So do you. If you multiply or divide by a negative when solving an inequality, you have to remember to flip the sign. That's why we have a greater than instead of a less than. When you graph linear equations and linear inequalities, there will be some similarities, but there will also be some differences too. We're talking about y equals mx plus b for linear equations. Graphing linear inequalities is very similar. So first you have to make sure that your inequality is solved for y. Then you use the y-intercept and the slope to plot your points on the line. The key difference is a linear inequality won't have an equal sign. Instead, it'll have a less than or greater than, or a greater than or equal to, less than or equal to sign. If it's a less than sign or a greater than sign, without the equal to, it'll be a dashed line. If it does have the equal to symbol, it'll be solid. The way I remember this is that whenever we would graph these type of problems, they would have an open circle. These ones would have a closed circle. So closed circle and solid lines, both are filled in completely like normal. Before we look at the next part of this, let's go ahead and start with an example on number 1 and try to graph that line. In number 1, even though it says y is greater than x plus 3, we're going to treat it like it's in slope-intercept form, y equals x plus 3. If this is in slope-intercept form, the y-intercept is 3, and then the slope is 1. So my next points would go up 1 over 1, or the other way, down 1 over 1. And then since this is a greater than symbol, without an equal to line, my line needs to be dashed. So I can just leave it right now as it is with those dotted or dashed lines. We're not done. Let's go back and consider the second part of graphing linear inequalities. We first draw the line, and then we have to shade the grid. If we're looking at a less than symbol, we would always shade below the line or underneath the line. If there's a greater than symbol, we would have to shade above the line. Looking back in problem number 1, where it says y is greater than x plus 3, do I shade above the line or below the line? You should realize you're shading above the line, so you literally just go like this and shade all those places above the line. That shaded area represents all the solutions to your linear inequality. We would call that the solution set. The solution set of linear inequality includes all the ordered pairs in the graph's shaded region. It also includes the points on the line if the line is solid. So if there's an equal to sign underneath of it, it would include those points on the line. However, points on a dashed or dotted line are not included in the solution set. Here's what that means in the problem that we looked at. We shaded all these points above the line, so everywhere in that shaded area is a solution to the inequality. So -5, 4 is just a point that I picked. It should work for this inequality. Let's try it. 4 is the y-coordinate, is greater than, -5 is the x-coordinate, plus 3. -5 plus 3 is -2, and 4 is greater than -2. So that's why this is a solution for the inequality. Any point you pick up here would make this inequality true. So what do you think would happen if you picked a point like 3, 2 in the non-shaded area, or even 4, 7 where it's on the dashed line, and you plugged those into the inequality? If you plugged in either one of these points into this inequality, you should realize that you should get false statements. 7 is greater than 7 is not a true statement. 7 is greater than or equal to 7, so this would not be part of the solution set. Same for this one. 2 is not greater than 6. So that's how you can kind of check your answers. Pick a point that's in the shaded area and test it, and if it works, then that is part of the solution set and you shaded the right way. At this point, we've got our 3 easy steps. Number 1, make sure the inequality is solved for y, and then graph it like normal. Number 2, make sure you have the right line, so it's either going to be dashed or solid depending on what kind of inequality symbol you have. And then the third step is to shade. You shade above the line if it's got a greater than symbol, or below the line if it's got a less than. Keeping that in mind, you should try number 2 by yourself and then press play when you're ready to check. All right, step 1, I'm going to plot my y-intercept at -4. The slope is -2, so I'm going to go up 2 and back 1, up 2 and back 1. I can also go down 2 and to the right 1. I've got my points plotted. Now I need to look at the inequality symbol to determine whether I should have a solid line or a dashed line. Because there's an equal to sign, it's going to be a solid line. And last step, because it's a greater than, I'm going to shade above the line. So you would shade all the numbers that are this way. If you have trouble figuring out which way to shade, pick a point and test it in your inequality. I think 0, 0 is probably the easiest point to pick, so I would plug it in, see if it works. Negative 2 times 0 is 0, and 0 is greater than negative 4. So that is part of the solution set. It should be in the shaded area. Last case that you might see is where it says y is less than negative 4. On the coordinate plane, that means that you would start by putting your point at negative 4 on the y-axis, and then this is a horizontal line because there's 0 slope, there's 0x. Your line would be dashed like this, and then you need to decide whether you shade above or below the line. In this case, it says less than, so you would shade below. Whenever you test out a point, you could still test out 0, 0. In this case, it's not in the solution set, so it shouldn't work for the inequality. And that's true. 0 is not less than negative 4. But if you pick a point that's in the solution set, for example, 0, negative 6, it should yield a true statement. Since negative 6 is less than negative 4, it should be in the shaded area. Number 4 and 5 are both linear inequalities that are in standard form. I would not try to graph these in standard form because you wouldn't know which way to shade above or below the line. So you have to solve for y before you can start graphing. When you've solved for y, now the inequality is in slope-intercept form. So you would then know that 6 is the y-intercept because it's the constant, the number that's by itself. The slope is negative 2/3. So you can go down 2 and to the right 3, or you can go up 2 and to the left 3. And when you've got your points, you can connect them because this has an equal to sign. So it would be a solid line. Then because it says less than, you would want to shade below the line. Next step is the final step. You'd want to test one of your points out. I always test 0, 0. I think it's the easiest to test. Then I would always plug your solution into the equation that you started with, just in case you made a mistake in solving for y. So for example, I would plug it into the x and y coordinate for the equation in standard form. 2 times 0 is 0, plus 3 times 0, which is 0, gives you 0 is less than or equal to 18. Since that's a true statement, we did our math right and our graph is correct. That was a good time for you to try number 5 all by yourself. Just be careful because there's a lot of opportunities for you to make mistakes. If you solved it like me, since the y was already on the right, I kept it on the right. So I added 10 to both sides and then divided both sides by 2. The thing about this is that it looks backwards because we're used to seeing the y at the beginning, like in the last problems we saw. I think it's worth taking a second to rewrite your problem starting with y. And then since the arrow is pointing to the y, we want to keep that arrow pointing to the y. So you're basically just flipping this around. And it's still the same inequality. I think we'll make less mistakes in shading when it's written like this. You'll still start just like we did on the other ones with the y-intercept at 5. And then your slope is up 3 over 1. Or down 3 to the left 1. You then want to make sure that it's a dashed or dotted line because it has that less than sign. Finally, and this is the important part, because we wrote that y is less than 3x plus 5, I want to shade below the line. So to test that out, I'm going to plug in the point 0, 0 into the original problem, and this should come out to be a true statement since it is part of the solution set. 0 is greater than negative 10. 0, 0, and all of the shaded numbers, all those coordinates are solutions for this inequality. The other thing we can do is write linear inequalities based on the graph that's shown. You do it the same way you would look at a 1 in slope-intercept form. You start with the y-intercept. In graph A, it's 1, and then you look for other points on the line. Because all the points are up 1 over 1, the slope is 1. Now I just write y, and then decide what kind of inequality symbol to use. Because it's a dashed line, and then we have shaded above the line, it's a greater than symbol, and then we know our slope is 1, so we can put 1x or just x plus the y-intercept where we started at, which was 1. Using that strategy to write the inequality, look at graph B and see if you can write the inequality shown. Hopefully you realize that the y-intercept is negative 1, the slope is positive 2 over 1, and because we have a solid line shading below the graph, we would use y is less than or equal to 2x minus 1 as the inequality for this graph. Daria believes that 2, 3 is a solution to both of the inequalities. Do you agree? No, it's only a solution on graph B. You can check this 2 ways. One, you can do it algebraically and plug it into the inequalities. And if you see 3 is greater than 3, that's a false statement, so it's not included in the solution set. However, 3 is less than or equal to 3 is a true statement because 3 is equal to 3. You can also see it on the graph. 2, 3 is on the dashed line, so it's not part of the solution set. Whereas on the other graph, 2, 3 is on the solid line. If it's on a solid line, it is included. And then the last 2 problems you should try by yourself and then press play when you're ready to check. 7, you don't have to graph it. You could just plug in the points and test it out. Number 8, you could do the same way. But if you wanted to use the graph, you tried shading above the line because you saw a greater than symbol, you would have made a big mistake. And that's because whenever you solve the inequality from standard form to slope-intercept form, you would have had to flip the sign whenever you divided by -5. That means that your inequality should look like this, and you'd have to shade below the line. Visually, you can see that 2, 4 is not in the shaded region. All right, that's it. Thanks for watching. If you have any questions, please let me know. Bye.